You've made a change to some SQL, so you need to check the results are still correct. Don't waste time by exporting it to Excel and writing VLOOKUPs. I'll show you how you can use the power of SQL to easily find any issues in the results or confirm that the results are unchanged. You've changed your SQL query, perhaps as an experiment to see if it performs better or to see if some new logic works. It's a good idea to check that the results are the same in your original query and your new query so you don't break something. You could export both results to Excel and write some formulas, but that's pretty slow and very manual. This is a problem that's easier to solve in SQL. Let's get started. I'll be using pgadmin on a Postgres database in this video, but the concept works on many other SQL databases such as Oracle, SQL Server and MySQL. The first step is to open both your original query and your new query. If you've got these saved as separate SQL files, or the same SQL file, that's great. Here we've got them saved as separate SQL files, opened in different tabs. Step 2 is to create a temporary table to store the results of your original query. Why a temporary table? This is so we can simplify our final query that compares data and use it multiple times. You don't need a temporary table. You could use a full regular table if you prefer. I've chosen a temporary table here because we don't need the data permanently. Another way is using a common table expression, which is even better. I'll show you how to do that later in the video. So we've created a temporary table here that stores the results of our original query. We can run this query and see that the table is created. Step 3 is to create a temporary table for your new query. It's the same as the previous step, but we just create a different table for the new query. Write a statement like this, then run it and your table is created. Step 4 is to write an SQL query to compare the data in these two new temporary tables. There are several ways to do this, such as using the minus or except keywords, or using not in, or not exists, or a left join. I would suggest using the minus keyword if you're on Oracle, or the except keyword on SQL Server or Postgres. MySQL doesn't support either of those. So in this video, to write a query that could work for you regardless of which vendor you're using, I'll use a method that works on multiple vendors, and that is using not exists. Here's how to do this. First, add a select keyword. Then add all the columns from the temporary table. You can type them in manually or use a feature in your IDE to generate all of the column names. Then we select from our original query's temporary table, the one we just created, which was query original. Then we add a where clause that says where not exists. We then open some brackets to write a subquery. In this subquery, we want to write select, then from, then the other temporary table we created, which was query new. We'll come back to the select clause shortly. Next, we add a where clause. In this subquery, we want to find records that match the row from the outer query, which will be excluded because of the not exists keyword. So to match the outer query, we can add criteria to the where clause to match each of the inner table's columns to the outer table's columns. In order to do this easier, it's helpful to add a table alias to the outer table and the inner table. I'll call the query original table QO, and the query new table QN. Depending on the number of columns in your table, this may include quite a few checks. Here's an example with this table. Now we can go back to the select clause in the subquery. The handy thing about the exists and not exists keywords is that they just determine whether a record is found or not found, and they don't care about the values. This means it doesn't matter what we add in our select clause. So I'll just add a 1 in here, because we need to select something, but it's not used. So it says select 1 from, then the rest of the query. Finally, we end the query with a closing bracket and semicolon. Our query is ready. The next step is to run the query. Run it inside your editor and you'll see a results panel appear. The results of this query represent rows that are in the original table but not in the new table. Ideally, you will see no results here, which means there is nothing in the original table that is not in the new table. If you do see some rows, like we do here, it means there is a mismatch. Now you might be thinking, what about rows that appear in the new query that are not in the original query? That's what we check next. So we can copy the query we just ran and reverse it. This should be as easy as changing the table names, but if you've renamed any columns, you may need to update those too. Now we can run the query and see the results. This will show us any rows from the new query that are not in the old query. We see no results here, which is good. It means that there is no mismatch. If you do see some rows in either query, you'll have to investigate. You may want to query each table and match it against the criteria in your queries, or compare it to the changes in your queries to work out why it might be showing in one and not the other. When you make an update to the new query, you can rerun this process of creating the temporary table and running both of these select queries again. This script will allow you to compare the data very quickly. You can just run the two create temporary table queries and then your two select queries, and you'll see the results. The only thing that you'll need to wait for is the temporary tables to get populated, which depends on the complexity of your query. So the outcome of this step is we saw that in the first query, there were a bunch of rows returned, meaning that our new query does not match the old query, and we need to investigate why. Right now, we've got two queries to create two temporary tables, and two select queries to check the data. We can combine both of these select queries into one. We can do that using a keyword called union all. This will combine the results of two queries into one result. It works well for this kind of query because the columns are the same. To do this, we remove the semicolon from the end of the first query. We add the word union all and then start the second query. We could use the keyword union here instead of union all, but I've chosen union all because union removes duplicate rows, and we want to see all rows. So we've got both of the queries combined. We can run this query and see our result here. This is simpler because we have one query to run instead of two, and one result to check. Looking at the result, we can see a lot of rows. However, we can't tell whether these rows exist in the original query only or in the new query only, because the two queries are combined. A good way to identify which of the two queries the rows come from is to add a label or a text value to each query. I'll do this by adding the word original to the first query and giving it an alias of query name. In the second query, I'll add the word new to the query. I don't need a column alias in the second query. If the result has the word original in this column, it means it appears in the original table and not the new one. If it has the word new, it appears in the new table and not the original one. We can run this query and see our results. We see the rows here with the value of original, so it's clear they appear in the original table and not in the new table. Now, there's a way to make this even easier to do. We can use a feature called a common table expression, or CTE. We can use this concept to replace both of our temporary tables with just one query that we run. It means there are fewer steps involved in running the query and updating it. The only drawback is that it may take longer to run, depending on the runtime of your original query, because you'll be running the full original query each time instead of getting data from the temporary table. So you can try this method, and if it works well for you, then great. But if you find the other method better, with the temporary tables and union all, then stick with that. Let's write this query. We start by writing a with clause, then give a name to our new query. This will be for the original query, so we'll call it original query. We then write as, then open and close brackets. Inside the brackets, we paste our original query. Then after the brackets, we add a comma and write our second CTE. We'll call it new query. Inside the brackets, we paste in our new query. After the end brackets of this query, we can paste in the two select queries with the union all query that we saw before. This is all still part of one overall query. Next, we change the select query at the end to refer to the CTEs instead of the temporary tables. So change the temporary table names to use either original query or new query. Our query is ready. We can run this single query and see our results, which we can see here. We see the rows that we saw earlier, indicating there is an issue. If you want to make a change to your new query to fix any issues you find, you can go ahead and do that. When you want to test it again, you can copy and paste it into this new query area here, and run this query again. I've just fixed the where clause here to add in another cost value, which relates to the shipping method that was in the original query but not in the new query. If you want to know more about CTEs, such as what they are, when and how to use them, check out this video. This process is a very helpful way of making sure you don't break your results when making changes to your queries. It works regardless of the specific method from this video that you use to write the query, and it should work on all SQL databases.